I've run into a bit of a problem with the AMC Eagle I'm rebuilding. It needs lower ball joints, but I can't find any, and that's because they don't exist anymore. They're totally obsolete. There used to be a ton of aftermarket options available, just like most other cars, but for whatever reason, only the upper ball joints are available now. All of the lower ones have been discontinued. Unfortunately, they're an absolutely necessary part of the front suspension. So I'm left with only one option if I want to keep this project moving forward. I need to find or make replacements. Your typical automotive ball joint has a tapered stud that engages with a matching tapered hole in the knuckle, and these are no exception. AMC used the common 7-degree taper on both the upper and lower ball joints on the Eagle, and, as far as I'm aware, all of their other cars. You might think that would make the uppers and lowers interchangeable, but that's sadly not the case. Though the stud angle is the same, the diameters are very different, with the lower being about 60 thousandths of an inch wider than the upper. And therein lies the problem. Even though there are many 7-degree ball joints out there, it's probably the most common ball joint angle, the specific diameter used on the Eagle lowers is extremely uncommon, outside of other AMCs. Pair that with the relatively short height and overall design of the joint, and finding replacements that will even come close to fitting is nearly impossible. And no, other AMC lower ball joints won't fit for several reasons, but mostly because they have an extended housing that interferes with the CV axle. There's no getting around that. Now, I knew this was going to be a problem even before I bought this car, so some time ago I came up with an ad hoc solution that I thought was going to work. I took an upper ball joint and modified it to work in place of a lower. The upper and lower ball joints share many similarities, including some of the same mounting holes. To make up for the difference in stud size, I fit a special tapered sleeve over the stud to increase its diameter. By some strange coincidence, sleeves of the perfect size already exist. They're used on early Bronco disc brake conversions to adapt tie rods. I got mine from a place called Tom's Off-Road. I also put a 10-gauge steel plate between the joint and the control arm. The plate does two things. It reinforces the end of the arm, just like the original joints, and it spaces the ball joint up off the arm enough for the rounded back of the joint to fit into the control arm's central hole. Without that extra spacer, the back of the joint hits the edges of the hole and won't sit flat. At least for these Moog ones I have on hand. This plate was really easy to make, by the way. I just split apart the old lower ball joints, cut off what I didn't need, and there you go. A steel plate with a perfect hole pattern for, effectively, free. I am not the first person to think of this particular solution. There is a company that sells these converted Moog upper ball joints. They choose to call them lower ball joints, but they're actually just some version of this. So this upper conversion design is what I was going to go with, until I actually put it all together and tested it. Once I did, I noticed immediately that the knuckle hits the rear outer fastener on turns. This didn't seem like a huge problem until I put a jack underneath the control arm and lifted it up to its normal ride height. That's when the full extent of the problem made itself known. There is serious interference between the control arm and the knuckle. The knuckle is supposed to be able to turn until the steering stop makes contact, but it's nowhere close to touching. Instead, the knuckle is colliding with the corner of the control arm and damaging it in the process. But here's the thing. I haven't driven this car with these ball joints on it, so where did this damage come from? Have I caused this by demonstrating the problem? No. Okay, I may have made it more noticeable by scraping off the spray paint, but the gouges were already here, and they're present in the same spot on both control arms. That means the old aftermarket ball joints that were in this car when I got it had this exact same problem. Or for all I know, maybe the original factory joints did. Whatever the case, I think it's unacceptable. I could probably get rid of some of this interference by adjusting the thickness of the steel plate between the ball joint and the control arm, and maybe the thickness of the sleeve on the stud to get the whole thing to sit a little bit lower. I don't think I could totally eliminate the problem, but let's give it a shot. Okay, these sleeves are a little too thick, so I took one, chucked it up in a drill, and held a file against it for about 10 minutes. Not exactly precision machining, but it'll do for now. It's about as thin as it can realistically be without falling through the knuckle, and it brings the ball joint down by about 150 thousandths of an inch. Next, I need a thinner plate, but not too thin or there's really no point. 12 gauge is about as slim as I'd like to go. I could try to grind these down, but I'll just make some brand new ones. I just need to learn how to use a CAD program real quick, recreate the design with some minor improvements, give SendCutSend the file and some money, wait 2 to 4 business days, and here we go. These turned out pretty nice, and they're about 30 thousandths thinner than the previous ones. That's 180 thousandths of difference altogether, not insignificant. So let's throw it on and see how it works.
Oh, that's not good.
And it still hits. I could try progressively thinner plates, but I'll just skip to the end and eliminate it entirely. With some creative filing, I was able to fit the upper ball joint in place without it. And this works. There's no interference. But I've got some reservations about losing the reinforcement plate. So I modified it to fit on top of the control arm instead of the bottom. This is not a bad solution, but I'm not exactly thrilled with it. I don't like using a sleeve. I like even less that I had to modify it myself. I don't like thinning the plate out or cutting corners off of it, and in the process of fitting these, I dropped one of these Moog ball joints on the ground from about 3 feet up, and it literally fell apart, which I definitely do not like. So, yeah, maybe not the best solution. Luckily, I think I found a better one. This is a Jaguar XJ40 ball joint, introduced on, you guessed it, the Jaguar XJ40. But it doesn't just fit one model, this is an update to an older Jaguar design, so it retroactively fits a whole slew of models over about a 20-year span. It was being used on new Jags right up until around 1997. I stumbled upon this ball joint via a forum post where 2 Jag owners were talking about some stud dimensions, and they were kind enough to include the actual measurements, which seemed oddly familiar. So I ordered the cheapest one I could find on RockAuto just to take a look at it, and yeah, the stud is the exact same size as the Eagle lowers. No special sleeve required. Jaguar is the only manufacturer, other than AMC, that I can find that used these specific ball joint dimensions. What's more, the overall design of the joint bears many similarities with the Eagle upper ball joints. The mounting pattern is quite similar, and the overall height, though slightly taller, is not too different. Initially, I considered mounting this joint in the same position as the factory one, on the bottom of the control arm, but I quickly ran into a few problems. The mounting holes in the Jaguar ball joint are somewhat closer to the center than the original joint, which is great for clearance because they're farther from the knuckle, but it means the dimpled hole in the center of the control arm would interfere with any fasteners. I thought about redesigning the reinforcement plate to go on the top of the arm again as a sort of spacer to provide a flat mounting surface. In fact, I didn't just think about it, I actually made it. But the joint is just too tall to allow this. Putting the plate on top doesn't change the overall height, everything still stacks up in the same way. But then I had another idea. One that required a little more modification. I try to stay away from modifying suspension parts, but mounting the ball joint like this drops the control arm relative to the knuckle. It's a minor change, but it's enough to totally eliminate all of the contact issues. The knuckle no longer hits the lower control arm or the fasteners. In fact, there's enough room to flip the screws upside down and run nylock nuts on the top. And here's the great thing about this design. The reinforcement plate can go on the bottom of the arm, like the original joints, but it no longer affects the height. I can make it as thick as I want, within reason. So, I did. I made a few tweaks and ordered some new ones. Because I had to remove some material from the top of the arm, I increased the thickness of the plate substantially to compensate. It's probably overkill, but at least I won't have to worry about this control arm bending anytime soon. Seeing some promise in the design, I decided to buy some proper ball joints, so I ordered Lemforder ones. I'm definitely mispronouncing that name. Lemforder were the OEM supplier for Jaguar, from what I can tell, and surprisingly I was able to find their ball joints for less than $40 a piece. Of course, there are a number of other brands available for significantly less, but I wanted to make sure I designed around the originals to avoid any trouble from whatever idiosyncrasies aftermarket joints might have. And I'm glad I did, because the super cheap ball joint from before is actually a bit different. It's missing this locating step at the base of the joint. It'd work as a replacement just fine, but if I cut the hole in the control arm to match the cheap joint, it'd be a little bit too small for the OEM style ones. Now there are some things about this ball joint which some people may not like. It uses a nylock nut instead of a castellated one, and it's not regreasable, it's sealed for life. Both of these are contentious issues and people can have very strong feelings about them. I don't want to get too far into them, but I will say that the original Eagle lowers were also sealed. And in this specific circumstance, sealed joints actually have one major advantage. Or it might be fair to say that the regreasable upper ball joints have one major disadvantage. And that's the Zerk fitting. With the CV axle installed, the problem is plain to see. The rubber boot rubs against the fitting. It may not look like much, but that boot will be destroyed pretty quick going down the road. There are other kinds of Zerk fittings with lower profiles and different brands of CV axles and replacement boots, so this problem could be avoided, but with a sealed joint, it's not even a consideration. There's more clearance than you could ever need. As for nylock nuts on ball joints, well, they're pretty common these days, and they work perfectly fine. But if you really wanted to, you could replace them with a castellated nut and drill a cotter pin hole. Believe it or not, these ball joints have the same thread size as the factory ones. However, I could not find a single account from the Jaguar guys of these nuts being a problem, so I'm not going to worry about it. While we're talking about the design of the ball joint, it's worth noting that the Jaguars this joint is used on have the coil spring on the lower control arm, meaning that this joint is normally loaded. It supports the weight of the vehicle. On the Eagle, that's not the case. The upper ball joint has that function. So this lower joint should be plenty strong enough for the application. Now you might be saying, hey, why not just use an Eagle upper ball joint like this on top of the control arm? Well, there's two good reasons. Firstly, you would still need to use a tapered sleeve. Modifying the arm doesn't eliminate that necessity, which means added cost and complexity. But more importantly, because the upper ball joints are noticeably shorter than the Jaguar ones, they drop the control arm farther down, which can cause interference, albeit in slightly different places. I'm not saying you couldn't make it work with the right brand of ball joint, but with the ones I have on hand, it's just not possible. And because the different brands of Eagle upper ball joints vary so much in construction, it's impossible to know which, if any, might work without trying all of them, which is a task I'll leave for someone else. I'm pretty happy with the solution I came up with, but this video took me a lot longer to make than I had originally intended. I hope you enjoyed it and maybe got something useful out of it. If you have any questions, please leave a comment. I'll try to answer them as best I can. And if you'd be interested in a Jaguar ball joint conversion kit, please let me know. That's something I've been thinking of putting together if enough people are interested. Thank you for watching. I'll see you later.